Hi, welcome to this next video in which I'm taking apart the BoseBuild headset and seeing what we can find out with that. So this is the setup I have. It's a little complicated. I will show you in a different video kind of a closer look at these circuit boards. So basically what I did was opened up the right and left headsets. I bodged some wires in parallel with these speakers, and then I hooked up my USB oscilloscope, the Analog Discovery 2, to those wires so that we can see the waveforms that are being sent to the speakers. They're in parallel, so that means the same voltage, the same weight, the same signal is being sent to the speaker and to the oscilloscope probes. So you can see that setup there, and then over here we're going to show you this is the waveform software. So this is the software for the Analog Discovery 2 that we're sending into our so this is the software that's communicating with the Analog Discovery 2, and then the Analog Discovery 2 device is reading the signals from the headphones and then sending those signals to the computer so that we can visualize it through this software. So I've got this headset Bluetooth paired with my phone, and once I hit play on that song, you can start to see the waveform that it's generating. This is only in the right headset. It gets a little, I'll show you, a little crowded with both. You can see they're at different voltage levels, so if we put that at the same, and when you listen to this song, there are differences between the left and the right headset, so it's interesting to kind of you can kind of see that there. I'm also wondering though if because the length of wire that I used to measure when I soldered to each headphone is different lengths. Here, like what I'm saying is like this length of wire is longer than this length of wire, and so I'm wondering if that difference in length is affecting the voltage level that we see, over here on our scope reading, right? Because what we're reading here is 1/2 volt peak for this sound wave, which doesn't really make sense. Like intuitively, I don't think you can drive a speaker with 1/2 volt, although I might be wrong. But I don't think that's right, because generally you need, I don't know, I would think you need more power than that. But this could be something that I don't know and that I'm learning. Just to show you some of the different ways you can view these waves, they got the shift and then the screen. See, what's nice about repeated though is that you can get repeated lets you get smaller divisions, so you can get a better look at the waveforms. The other two options don't really let you get this granular. I'm going to turn this off so you can just see that. And, you know, this isn't necessarily useful information, it's just interesting to see. What's going to be more interesting is taking this idea that the peak waveform is 1/2 volt and then using the wave generator. So to show you, so the USB oscilloscope, this guy, it's not only an oscilloscope, it also can create its own wave. So using some of the wires here, we can input our own signals into these speakers in parallel with these speakers to see if we can create tones with them. So we'll do that in the next video. Thanks for checking it out. We'll talk to you next time.